Hey everyone, and welcome. We're about to jump into a really cool space where two worlds you might not expect to see together collide. We're talking about the sports field and the robotics lab. We're going to break down how the thrill of a game is actually being used to teach the building blocks of technology. And it all kicks off with a pretty interesting question.
I know, right? It sounds like the setup to a strange joke. One is all about muscle and momentum. The other is just pure logic. But believe it or not, there's a powerful connection between them, and it's completely changing how we can teach some really fundamental STEM skills.
And there it is. That's the big secret. You give a student the challenge of building a robot to mimic a sport, and suddenly all those abstract ideas like physics and programming, they become real, they become interactive, and let's be honest, they become a whole lot more fun.
Okay, so just like any good athlete, you've got to start with the basics. The same goes for any programmer. So for students, lesson number 1 is all about mastering those fundamentals. We're talking pure cause and effect, how to turn a simple command into a real physical action.
The first thing a teacher needs to get across is that feeling of immediate feedback. A student types one simple line of code, and bam, they see a robot's arm swing like a hockey stick. That direct one-to-one link is everything. It's the absolute foundation of what's called computational thinking. Being able to see a big problem and break it down into tiny, logical steps.
And the piece of tech that makes this all possible? It's the servo motor. Teachers introduce this basically as the robot's joint. See, a regular motor just spins and spins, but a servo gives you precise control. It's exactly what you need to simulate those specific movements, like swinging a bat or lifting a weight.
So a teacher will set up a really simple challenge to bring this home. Make your robot lift a weight. This is where students get their first taste of event-based programming. They learn to connect a button press, that's the event, to a specific action. You press button A, the arm goes down. You press button B, it goes up. It's so simple, but seeing it work is incredibly satisfying and really builds that early confidence.
All right, so once students have the whole direct command thing down, it's time to level up. The next lesson is all about giving the robot senses. We're teaching them not just to act when told, but to react all on their own to the world around them.
And the key idea here is something called conditional logic. You've probably heard of it as if this, then that. This is the heart and soul of all automation. It's the code that makes a machine seem like it's actually thinking for itself.
Now to do this, students get to work with some new hardware, a line tracking sensor. You can think of this little device as the robot's eyes. It gives the robot the ability to see a line on the floor, which is crucial for knowing when it's about to go out of bounds.
And what's a better way to teach the concept of staying within boundaries than a sport that is literally all about that? Sumo wrestling becomes the perfect, fun framework for a lesson in automation and, well, spatial awareness.
The teacher's instructions are super clear, just like the rules of sumo. The challenge is to make the robot totally autonomous. It has to move on its own, try to push its opponent out, but most importantly, it has to know how to stay inside that ring.
So the logic the students have to code is actually pretty straightforward. If the sensor sees that black line, then the robot has to back up and turn around. And if it detects an opponent in front of it, then it pushes forward. They are literally programming a robot to make its own decisions, and the result is this awesome, chaotic, and fully autonomous competition.
And now we get to the final boss level, the most advanced play. In this part of the curriculum, the lessons go beyond just one robot thinking for itself. Now students have to figure out how to make two completely separate devices talk to each other from across the room.
So the big lesson here is wireless communication. This is a huge leap. It's not about programming one robot's brain anymore. It's about programming an entire system, a controller that sends signals and a robot that receives and acts on them.
And here's a look at how that actually works. The students have to build this communication map themselves. They decide that pressing button A sends a specific radio signal, like the letter F, which the robot is programmed to understand as move forward. What they're learning here are the absolute fundamentals of remote control and even user interface design.
And once they understand that core concept, you can apply it to a ton of different sports. So whether the students are programming a fencer or an archer or even a basketball player, they're just practicing that same core skill over and over, making two different machines work together perfectly.
So we've gone through all these games, all these challenges. What's the big picture payoff? Well, it turns out that teaching this way has some incredible benefits that stretch way beyond just the playing field.
See, at its heart, this curriculum isn't really just about coding. It very cleverly weaves together 6 different educational areas into one single, really engaging experience for the student.
And when you look at how it all breaks down, yeah, programming and engineering are the biggest pieces of the pie, but they are not the whole story. Students are also getting hands-on lessons in using sensors, in teamwork, in pure problem-solving through trial and error. It's this whole package that makes the learning feel so complete.
But really, the ultimate lesson here is that aha moment. It's that spark when a student finally realizes that these abstract lines of code on a screen can actually be used to model and directly affect something physical and real right in front of them. That connection is priceless.
There's a quote from the source material that just sums it all up perfectly. By grounding these really complex tech lessons in something as familiar and fun as sports, teachers are making these ideas way more accessible, and at the same time, they're building a rock-solid foundation of STEM skills for the future.
And that kind of leaves us with a really big question to chew on, doesn't it? If this approach works so well, if we can use the excitement of sports to unlock something as complex as robotics, what other passions are out there that we can tap into to build the skills of tomorrow? It really makes you think. Thanks for digging into this with us.